Good morning, everyone. It is with great pleasure that we would like to introduce you to yCov, a system to combat misinformation on social media that we have developed over the past few weeks as part of the COVID-19 challenge. We are a team of four with my mentors, Dr. Suranjana Samanta, Dr. Amar Prakash Azad, my fellow mate Mohit Bhadwaj, and myself, Divanjana Kaur. We will walk you through the developments of the project, mainly providing a high-level overview of the entire system with a live demo towards the end. Ashwathama Hatha iti Narova Kunjarova. We are all very familiar with this famous scene from the Indian epic Mahabharata, and it's probably one of the most classic examples that demonstrates the misuse of fake news. Distinguishing fake from authentic news has always been a task of utmost importance in the field of NLP as well as in our day to day lives. If analyzed deeper, one can observe that social media is the platform where misinformation is the most prevalent and is easiest and fastest to access. Needless to say, fake news on social media spreads like wildfire, and the adversaries that it can cause are extremely grim, more so ever given the COVID-19 situation. This formed the motivation for us in taking up this task and exploring efficient ways of telling a fake tweet from an authentic one using NLP methods with special focus to the pandemic situation. We also throw in a dash of novelty to our task by extending our work to accommodate Indic languages. Given the rise in regional language tweets, we realize that this might be a helpful feature. So, before we delve into the technical details, let us first gain some insights from the dataset perspective. The dataset that we have used is the infodemic COVID-19 Twitter dataset, and it is the only COVID specific misinformation Twitter dataset to the best of our knowledge. The dataset is a multi-task dataset that has been annotated keeping 7 questions in mind. For this task we stick to the annotations for only one question, that is whether the tweet contains any verifiable claim or not. The next task in the pipeline for us was to infuse Indic tweets into the dataset. For that, we made use of the Google Translate API to translate the English tweets of the dataset to Hindi and Bengali, and then we filtered out only the good translations from that. We also made fresh annotations of around 100 Bengali and 105 Hindi tweets for this task, and we developed required tools to scrape and process the Indic tweets as well. So after all these processes, the dataset looks something like this, and overall we have around 1400 annotated tweets. Now Mohit will walk you through our general architecture and some of the classifiers.
So we extracted various tweet features and user features. So the normal trend that we used to see earlier in fake news detection was that the users with more retweet count and favorite counts generally used to be more correlated with the label of the news. But as you can see that retweet count and favorite count is negatively correlated to label. This is because in this pandemic, the users, even the verified users, as soon as they get some sort of rumor or an information, they want to spread it to their loved ones or to the people they know, and that is why a lot of misinformation is being spread out on social media. We have handcrafted a lot of features as well, such as length before pre-processing and length after pre-processing, and we can see that they are highly correlated with our labels as well. These are the list of various user features that we have extracted, and we have created a lot of them as well. The most prominent one in this one is the verified one, whether the account is verified or not, and the other ones that we created handcrafted were like characters in real name and characters in username. So the number of matches that we have in both of them is called number of matches, and that is also positively correlated. Another feature that we extracted was posting frequency, and that was also positively correlated. So moving on to this slide, in this slide we'll discuss the entire solution pipeline and the general architecture that we have followed throughout. Starting with the infodemic dataset, we augmented multilingual Hindi and Bangla dataset to it. Moving on to the pre-processing bit, on top of our basic NLP pre-processing, we had to remove all the emojis, all the URLs mentioned in the tweet, all the hashtag, all the user mentions, not the hashtags, because hashtags are very important as they have those key terms, and all the RT from the beginning of retweet. So now moving on to the most important part of our project, this is a general architecture uh, how we classify whether a tweet is real or fake. So we ask the user to enter the tweet ID or the URL of the tweet. We extract the tweet text from it, pre-process it, get BERT-based embeddings out of it, and augment them with various supplementary features. Concatenate them all together, pass it to a classifier, and let the classifier predict whether the tweet is real or fake. In this slide, we will discuss our monolingual classifier architecture. In this one, for the BERT-based embeddings, we have used BERT CLS, Sentence BERT, Sentence Roberta, that is fine-tuned on NLI dataset. And as for the supplementary features, we have used 10 tweet features such as retweet count, favorites count, etc., and 19 user features such as followers count, friends count, and many handcrafted features like the account life or the number of days since the user last tweeted. The general trend that we have seen for the SVM based models is that on addition of more features, the accuracy has been dropped significantly, and this is because of such small dataset and such a large feature vector. We have also fine-tuned multilingual BERT on one language at a time, and we have got quite decent results just by using the text embeddings. The best model here that we have got is using BERT CLS embeddings and random forest classifier, and this model is even able to outperform the SOTA on this infodemic dataset by 2%. The features that we have used for this model are embedding plus tweet plus user features, everything combined together.
Okay, so in this slide, we will be talking about our various experimentations in the multilingual setting. Given that the number of data points are less, it's only logical that we employ some transfer learning mechanisms to this task and observe its effects. So in this experiment, we fine-tuned the birth sequence classification model on our dataset and reported its results in both the multilingual and cross-lingual setting. As expected, with very few epochs of training, we observed remarkable results. In fact, the best results so far in the multilingual setting is from this experiment. Moving on to the next experiment, we obtained the tweet embedding by passing pre-trained embed word embeddings through a BiLSTM model, followed by max pooling. The other features were also passed through some stack layers, after which it was concatenated with the obtained tweet embedding and classified using a simple FC layer. So in this experiment, we have also used some interesting text-based features like the link score, the bias score, and the class weights. A quick description of the features used. The link score is the Levenstein distance ratio of similarity between the tweet and the titles and descriptions of news articles that were mined on querying the tweet in the Google search engine. The bias score is the probability of a string containing offensive language. The class weights are nothing but the weightage given to each class with a previously fine-tuned transformer model. So this was a bird's eye view of our experiments and architectures and the system at large. So now we will move on to the most exciting part of the presentation, that is the live demo.
So let's move on to the live demo. So this is a GUI that we have created for the यCov. So we need to enter the tweet ID here of whichever tweet we want to verify. So let's start testing. So in this tweet, it says that taking a bath with extremely hot water will prevent coronavirus. Now the tweet itself is saying that this is a false claim, and yes, this makes the overall tweet a verified tweet, and yes, this is a real claim. So let's test this. As we can see, our predictor is also predicting that this is a verified tweet, that is, it is a real claim. So let's test another one. So this is the original tweet which says that India overtakes Russia as the third worst hit nation in the COVID-19 tally, which is actually true. But this is a reply who is saying that who is responsible for all this? Tablighi Jamaat. Now this is not at all a verified claim. So let's see how our model behaves. As we can see, our model also predicts that this is not a verified tweet. So moving on to the multilingual aspect of our model, this Hindi tweet is basically trying to say that this is the vaccine for coronavirus, and yes, this is definitely a false claim. So let's test this as well. Yes, as we can see that this is not a verified claim, and the interesting thing to note with this example is that even the user is verified and it has a decent number of likes and retweets, and still the model is able to somehow predict that this is not a verified source. Devanshana will explain the meaning of this tweet, and then we'll test it as well.
Right. So this tweet talks about WHO not dismissing the fact that COVID-19 can be airborne. It's a verified tweet, and let's see if our model can predict that.
Okay, so maybe I didn't copy, my bad. Okay, yes, it is a verified tweet. Okay, so
Right.
moving on to this example will show the caveats in our model. Now this tweet is an example of where majority of the things said by the user are true, and the and they just wrap a small lie around it. Like this, they are saying that China has 9 crore positive, like 9 crore tests for COVID-19, which is false because no one knows what the actual numbers for China are. But like the majority of the stuff here is actually true. So this is where our model fails, and we'll show it right now. As you can see that the model predicts that this is a verified tweet, so this adds up to the false positives to our model, because the model is not able to predict, because various verified users with such high amount of likes and retweets as well are also spreading false information by wrapping them in very good truths, as you can see. So moving on to the introspection part, we can say that even with such small data sets, we are getting promising results on both cross-lingual and multilingual models. Our model is flexible enough in adapting to new features. Our model even outperforms the SOTA on the infodemic dataset. Moving on to the demerit analysis, it has been observed that more and more verified users are spreading false information. The second demerit of our model is that this is a supervised model. That is, it cannot adapt to the dynamic changes in the nature of the tweets. For example, what if a tweet is real today and it might become fake tomorrow, or vice versa?
So, given the merits and demerits of the system, it paves way for us to outline the future scope of this project. We would like to include fresh annotations, which would help us extend the system to other Indic languages. We want to integrate more features into the multilingual bilistein-based classifier and also test it with embeddings obtained from the fine-tuned transformer-based classifier. This, in our opinion, should further enhance the results. For the system to be more robust and practical, creation of machine teaching based classifiers to adapt to the dynamic nature of tweets is essential in our opinion. We want a model that continually imbibes fresh data and learns from it while already in use. So that more or less brings us to the end of this demo or presentation. Thank you so much, and we hope you liked our presentation. Thanks.